Hello guys, in this video we're gonna solve a knapsack problem using bottom-up approach. In the previous video we've gone through this problem using top-down approach, which is we're trying to solve the original problems top-down, right? By asking questions and trying to solve the sub-problems, right? As you can see here the illustrations of top-down approach, right? But for the bottom-up approach, we're not gonna start from the original problem, but we're gonna start from sub-problems and build up from that, so that we can calculate the answer at the end, right? So in terms of bottom-up approach, normally we will use a actually most of the cases we use a two-dimensional matrix, right, to represent the answer for sub-problems. So let's say, right, our problem is to find the best profits, to find the best combinations of items that generates the maximum profit, right? That is our questions. Given the capacity phi, right? So for bottom up, we're gonna start to solve the problem that considering considering one items at with capacity of 0 first, right? Wanna build up our 2D matrix where a cell in the matrix represent the answer for our sub-problem. So for example, as you can see in this cell, it will represent the answer, the max profit, considering two elements A and B, right? For example, we are at this row, so we are considering all items bottom up, right, from B to A to B, right? And with the capacity of 1, right? So the idea is that we try to solve the small problems first, right? And so that we can gradually combine these sub-problems, small problems, to find the result for bigger problem. So for the 2D matrix, we also assume that we know the answer for case that, for examples, right? For example, in the first row, it means for the first row, it means we're assuming that the item lists are empty, right? So because the item lists are empty, then no matter our capacities, how much our capacity is, the max profit is always 0, right? And we also assume that if our capacity is 0, no matter how many items we're considering, the maximum profit is always 0. So as you can see, the 2D matrix, first row and first column is all 0. So we start build up from the first from here, which is considering only item A, considering only item A, and if our capacity is 1, what is the best profit we can generate? So at each cell, same as there's a little bit similar between these the bottom up and top down approach. Like at each step, we need to consider 2 cases, which is firstly we take the current element, right? And the second case is that we don't take it, right? So if we take the elements, because our capacity here is 1, I think let's try to delete all of the here, and we start to build our 2D table from scratch. Let's say so for capacity of 1 and our only items is A with the weight of 2, there's no way we can generate profit, right? So the profit is 0, the max profit is 0, right? So we want to build up our 2D matrix from top to bottom, from left to right. So the next one is here, which means considering item A and our capacity 2. So it's obviously that the best solution is that we take the A, right? We take the A. So the profit we can generate is 4, right? So we enter 4 here. The next elements, consider A, our capacity 3. So the best thing we can do is take A, and we still have 4. But in this case, our capacity is not full, right? Our knapsack is not full. We have one more left. We have one more unit to store, but because we only have one A element, we're not considering A. We are considering A. So that's the best thing we can do is just 4 here. So it is the same for every cell in this row because we only consider one element, and the best thing we can do is to take it, right? Moving to the next row, it means considering A and B. If our capacity is 1, as you can see, both A and B is greater than 1, so there's the best profit is 0, right? So now at this cell, considering A and B, our capacity 2. So obviously there are two choices here, either take B or skip B, right? If we take B, no, we cannot because our capacity is 2, so it's not. So the best result is that comes down to problem of considering only A with capacity of 2. So it's actually the result of current cell is actually taken from the above cell, right, which is 4, right? The next one, considering A and B, our capacity 3. So again, 3 cases. If we take B, yeah, we can because our capacity is 3, right? And the weight of B is 3. So if we take it, the profit we can generate is 5, right? That the profit we can generate is 5. And if we don't take B, then the max profit is the cell above, which is considering only A with a capacity of 3, so it's 4. So if we take B, we can have 5, and if we don't take B, we have 4. So obviously the best answer is 5. Next, over here, capacity 4 considering A and B. If we take B, we have 5, right? 4 minus 3 is 1. We have 1 unit left, but we cannot do anything with that unit. So the best thing we can do is 5. The best profit is 5 in case we take B. And same here, if we not take B, we take the result from the above cell. So it's max of 5 and 4 is 5. This one is interesting. If we take B in this guy, then we have 2 left, right? We have 2 units left. And if we have 2 units left, the question is what is the best profit we can generate if the capacity is 2. So we can find the problem, we can find the answer for that problem in our matrix. So for capacity of 2 and not considering B because we already take B, then is this one, which is 4. So 4 profit of 4 plus profit of 5 because we take B, so it's 9, right? So if we take B, the best profit we can generate is 9. And same here, if we don't take B, the best profit is 4. So here is 9, right? And so on. So I'm not gonna fill out the whole table because you know the logics already, right? So let's start to code it out. I'm gonna delete this one, so we're gonna start from scratch. So for this problem, find max profit. Bottom up, we take in the profits. This is a list of profits for all items. Weight is a list of weights for all items. Capacity is the capacity of our knapsack, right? So for this problem, we're gonna start initializing a 2D table, 2-dimensional magic. Let's call it DP. So I'm gonna generate magics of let's say we need to know how many rows and how many columns, right? So as you can see here, the rows is the number of items. For example, we have 4 items plus 1 rows representing that we're not considering any elements, so the number of items plus 1, right? Last controls is the number of items. It can be is the length of profits list length plus 1. What is the column? The column is the capacity, right? So for example, our capacity is 5. Then the number of column is capacity plus 1, right? Plus 1 the the first column represent that we're considering capacity of 0, right? So we're gonna start from 0 to capacity, so their total of capacity plus 1. I'm gonna write the function generate magic. This will take in rows and columns. So I'm return a array first. Arrays of rows. Array of for example, there are 10 rows. I'm gonna first create 10 array. One array. I want to create one array of 10 items first, right? I'm gonna fill it with, can be anything, just to fill it with 0. Then I'm gonna map with each items in this array. I'm gonna map it with new array upside calls, which is the number of columns. So, and for each items in this one, I'm gonna fill it with 0, right? So I wanna have a 2D magic from these functions. Let's check it out a little bit. Not okay. Generate magic. Let's say 3 and 3. Okay. So it's 3 rows and 3 columns. Let's say 3 rows and 4 columns. Okay. It works. So we're gonna start our magic. So assuming that we know the answer for first rows in first column, right? So wanna start build up our magic. Let row equal to 1, row less than number of rows, row plus plus. So the row here is represent for items we are considering, and the column start from 1 also. Column less than call plus plus. Okay. So the column here represent the capacity we currently have, right? So for each cell we want to find the best profit that we can have from the items we are considering with the capacity constraint. So there are two cases, right? Either take it, profit, max profits. If we take it here is the item we are considering. For example, we are consider this one. We take B, right? If take it, let's say 0, max profit. If skip it, also equal to 0. So after we calculate these two, we want to find the best one, save to the value to the current cell. So dp row and column equal to math. I want to get the maximum of these two values, max profit if skip it and max profit if take it. So after exit the loop, we have filled up our table. All cells are filled up. So I want to get the value of this one, final row and final columns. So this one will store the value of the past profit we can generate considering all 4 elements with the capacity constraints of 5, which is the original capacity, right? So after all, I'm going to return dp dot rows minus 1, calls minus 1, which is the last index of rows and column. So let's try to to do is these two functions, these two calculations. So if we take the current element, what kind of we need to be cautious, because the current item is our capacity is way less than the current item we take in. So we don't want to take an item if it is larger than our capacity, right? So we only want to, if the capacity, let's write pseudocode for it first. If current capacity let's say current item weight, current capacity is greater than or equal to current item weight, then we want to calculate the profits if we take it, right? Max profit if we take it equal to something. So current capacity, what is current capacity? Current capacity is actually the column, right? The current column. So if we are here, then column is defined, right? Means capacity is phi. So current capacity is actually the column, current item weight. So let's say, as you can see, as we add one more row here, so the index, for example, item A is the first item you're considering, but it is in row number, it rows index 1, right? This row is 0 index, this row is 1 index. So the current item weight is actually, we want to take from the weight array, but we want to take it at index row -1, right? A is the first item in this list, right? But here we are at row 1. So in order to get the correct value, we need to -1, right? So if the capacity is greater than current weight of item, wanna take it. The max profit the profit is the weight of current the profits of current items, because we decide to take it here. So the profits is the same. We also access by row -1. The profits of current item plus what? Plus the profit, the best profit we can get if we're not considering elements, which is we take it from the above row, right? We can get the result from the previous calculations, which is row -1, up one level. we take it, so we wanna eliminate it out from our choices here. DP is best profit. If we're not considering current item and the profit and the capacity is what? Current capacity is column, right? So we need to minus the capacity with minus the weight of the item we've taken, which is weight of row minus 1, right? So if we take it here, the profit, the maximum we can have. Otherwise, if we don't take it, we decide not to take it, then the max profit is actually one cell above, which is we're not considering current element, right? And because we don't take it, so we keep the capacity, which is call in this case, the same, right? So after here we find the max to. Okay, that's pretty much it, I think. I'm gonna run the test. Okay, it works. So that's it for knapsack problem using bottom-up approach with 2D matrix, solving the sub-problems first, gradually build up our matrix, and finally the result for the final answer is the last calculations that is built up from previous calculations. So that's it. Thank you for watching. See you in the next video.